While they're getting Dr. Kittles' presentation up, I will introduce him. My name is Jim Evans. I'm a medical geneticist here at UNC, and as a geneticist, I'm really excited to see the lineup that Fatima Jackson has arranged. It's just an incredible set of people and an incredible set of subjects to be addressed at this fascinating conference. And as a geneticist, genetics is really all about origins, as the etymology of that word would indicate. The origins of traits, the origins of diseases, the origins of peoples. So there really could be no more appropriate focus for a conference having to do with genetics than the genetics of the peoples of Africa, from where we all derive originally. Now, I'm here to introduce Dr. Rick Kittles, and his origins are astoundingly recent. I've been familiar with his work and was excited to get to introduce him. And I thought there must be a typo in the information I got, because it said that he had gotten his PhD just in 1998. But it turns out he got his PhD just in 1998. He's currently the director of the Human Institute of Genetics at the University of Illinois at Chicago. But in that really short time since he got his PhD, he's been incredibly prolific and influential in academic pursuits, publishing over 85 research articles on important topics such as prostate cancer genetics, race and genetics, health disparities, and he's been one of the real leaders in the development of ancestrally informative markers. His influence, though, has extended far beyond the academy, as is really appropriate for a set of subjects that are so important in a broader social context. He's a tremendous communicator, as I think we'll all see in a couple of minutes. He's been featured in 5 PBS and BBC network documentaries related to human biological diversity, to race, and to disease. He's also been selected one of Ebony Magazine's Power 100, and he's been interviewed by Leslie Stahl on 60 Minutes. So I think we're all in for a tremendous treat. And he does look as young as that 1998 figure would suggest.
Thank you. Thanks a lot. All right, pleasure meeting you too. Wow. So I guess I have nowhere to go but down after that introduction. So just bear with me. I'm a bit congested as always because of allergies. So I'm quite excited to be here and humbled. I just want to thank Dr. Fatima Jackson and the organizers of the conference, this conference, which I think is not only timely, but it's finally come, and something that I know many had wished we could have done this a while ago, and so I'm excited about all the participants, the speakers, and so today I'm going to dwell a little bit and tell you guys some stories about some of my work as it pertains to understanding ancestry. In particular, we're going to talk about paternal lineages in African descent populations. But I'm also going to sort of place it into context as it relates to not just ancestry, but health of African Americans. And I'm sure some of you may be a little surprised because I will get a bit animated and excited about what I'm going to talk about. But it's because this is more than just a scientific venture for me. This is also, in a sense, political. And I guess I can get in trouble for saying that, but, you know, hey. Not only is understanding ancestry for African Americans important, but it also is important also for understanding family history of disease. And so when I see a lot of gaps in the scientific literature pertaining to that, then, you know, I get concerned. And so we'll talk some about that and what are the implications for some of the stuff that we actually are going to be talking about over the next couple of days in terms of African genetics. So I guess 1492 is a good starting point, right? I guess that's when sort of the world became closer. But it was also an enormous time in terms of West African history. Gold was being discovered once again and mined. Populations were being shattered. Individuals of West and Central African descent were being kidnapped and brought to the New World in disproportionate numbers. In fact, one of the largest forced migrations in history. Some call this the Maafa, right? Or the Holocaust, the transatlantic slave trade. And so with that became sort of this period of gaps in cultural, traditional language and family ties. The descendants of these enslaved Africans in the New World, me being one of them, sort of became lost in terms of understanding deep family history. So we think about the transatlantic slave trade, the numbers, you know, there's a lot of debate. I'm not even going to get into it, but let's just say 10 million. Okay, a large number of these individuals actually went to South America and the Caribbean. Some scholars believe only about 500,000 went to North America. So from 500,000, we now have, what, 35 or so million African Americans, or people of African descent. The bulk of them are direct descendants of enslaved Africans. So if we look in the Caribbean, and some of this work I'm going to talk about now is work that Jada Ben Torres, who was a postdoc in my lab, did. She's now at Notre Dame, University of Notre Dame, I guess you say it right, in the anthro department. So about 10 million enslaved Africans brought to the Americas, about 4 million, some estimate, were sent to the Caribbean, and about 1.5 million were sold in the British West Indies in particular. Remember, you know, the transatlantic slave trade was business, and so not only were there companies, but there were countries and regions that were involved, all in cahoots in this very profitable venture. So what Jada did was quite interesting. She actually jumped around from island to island one couple of summers. It was very hard work. And she was able to collect samples from the English-speaking Caribbean populations. And when we looked at some Y chromosome variation in these populations, we found that it varied enormously across the islands. And in particular, the island of Dominica, where there's still many Native American reservations, having the least amount of West African ancestry and the largest proportion of Native American ancestry. I think the largest we saw was in the St. Kitts area. Also, St. Thomas was very, very high, too, for West African lineage diversity. So when we look at African Americans, because of this, the movement, the forced migration of enslaved Africans, but then also gene flow with non-Africans, mainly European men, and to some extent Native Americans, though many African Americans claim Native American ancestry. It's difficult at times to find it. I think it's always your grandmother with good hair. I think it is, and high cheekbones. You say, oh well, yeah. But then I found out, you know, actually in some families, I won't get into that. But anyway, the high genetic heterogeneity in the African American population, mainly because of the antiquity of being African. These are very old populations in West Africa, very diverse, large population size historically, a lot of movement throughout the region, and this causes increased linkage disequilibrium. And you've heard a lot about that from Dr. Tishkoff, and you'll hear more later. The pattern of variation differs geographically in the United States. So, you know, I think when you guys leave here, I think everybody will be in agreement that there is no monolithic or homogeneous African American or African population in the Americas. Very diverse, and each one of them having their own sort of local histories, social histories, which impact the variation that you see. So we always should think about this in a particular context. When we look across different regions in the Americas, each had different social histories. It's also this high level of population stratification because of all of this linkage disequilibrium due to admixture. And this can confound association studies. I'll talk more about that later. But this is my CNN map, and you see where the bulk of the enslaved Africans, about 95%, northern Senegal, southern Angola, and about 5% from East Africa, Mozambique, and Madagascar. Now, what I find interesting is, I'm in a very contentious field, called genetics. And I think the only other contentious or as contentious field is history. And in particular, the historians of the transatlantic slave trade. So they debate which region contributed the most in terms of enslaved Africans. It changes throughout the years. I'm not even going to get into it, but just know that this is a very rich region in genetic and cultural diversity. Okay? These are not all, quote-unquote, Yoruba from HapMap. These are extremely diverse populations with their own sort of histories. And I think we need to really understand that when we try to relate that information to Africans in the Americas. So one of the questions we had, and this goes back actually when I was at Howard University, a graduate student of mine, Menachem Dora, was interested in looking at Y chromosome diversity to answer the question as it relates to the ancestry of African Americans in South Carolina. And we knew, based on history in the region, that rice was big in South Carolina. It was really the big crop during the emergence of the plantation complex. It was one of them at one point. And so these regional preferences ensued for enslaved Africans that were based on actually the principal cash crop. And this may have led to some stratification geographically of the African American gene pool. So in South Carolina, the cash crop was rice. And at one point it was indigo, but we want to focus on rice because of what we know about the West Africans that knew actually how to grow rice and had been growing rice even before they were enslaved. So this map shows the different regions in the Americas early during the period of the slave trade. And this region here, I guess the original colonies, you'd say, was British-run. Spanish controlled Florida, and French controlled Louisiana. So remember, we had private entities involved in the slave trade, but also countries also gained a lot because of their land ownership and the opportunity to exploit the labor of enslaved Africans. So each one of these, I like to say this because it's interesting. We think that Europeans are homogeneous, but they're culturally diverse too. Actually, each one of those had their own way of interacting with the enslaved African. In fact, the British, they created all those laws of anti-miscegenation, one-drop rule, all of that, to maintain money and power. And the Spanish were actually almost like absentee landlords. They just weren't around much, just send the money and the sugar, which is why there's a lot of fighting in Florida. I'm sure the historians are going to be mad at me today. The French behaved quite differently. They actually promoted the mixing of the groups. We know historically, and particularly in Louisiana, the placage system and when these young Frenchmen started to gain a certain age, they would then sow their oats with the enslaved African women. So anyway, each one of these having their own sort of social experiences and interactions with the enslaved Africans actually had a lot to do with what we see when we look at the genetic diversity in these regions. So back to the black rice hypothesis. So West Africans from the Grain Coast, what is within historically been called Upper Guinea, this is from Senegal to Sierra Leone, had considerable expertise in rice cultivation. We know this. Many books have been written on this. This led plantation owners in South Carolina to prefer enslaved Africans from the Grain Coast. So that was our hypothesis. In fact, historical, linguistic, and cultural studies suggest a continuity in, between African populations in the Sierra Leone region and African Americans from South Carolina. So, in fact, there were many anthropologists who studied sort of the linguistic continuity between these groups. So this is an old map showing the regions that I'm talking about. So when I say Upper Guinea, I'm talking Senegambia, Sierra Leone, Liberia. Actually, Liberia is what would be considered officially the Grain Coast, but this region is what's considered Upper Guinea, and so we sampled from this region and denoted these groups as Upper Guinean groups. Lower Guinea, which is from Ghana, Nigeria, and the Niger Delta region, some parts of Cameroon, and then Angola here in West Central Africa. So actually, what I'm going to talk about was recently published in PLOS One, work done by Jada and Menachem. Actually, it was probably started about 8-9 years ago. And my buddy, Dr. Keita, actually contributed to this. I think you'll hear from him later today or tomorrow, which should be quite exciting. So the objectives for that particular study were to assess the level of Y chromosome diversity in populations of African descent and determine the genetic relationships in particular among African Americans from South Carolina and West and Central African populations. So the African populations that we looked at for this particular study were broken down in those regions, as I mentioned, the Mandinka from Senegal, Mende, Temne, and Kru, Mende and Temne from Sierra Leone, and the Kru from Liberia. And then populations from the Bites of Bani and Biafra, which represent Nigeria and Cameroon, these populations from the mid-northern part of Nigeria all the way down to the Niger Delta, the Wari Delta region, and the Bamileke from Cameroon, representing the populations near Calabar. The African descent populations in the Americas were sampled from Washington, D.C., African Americans and African Americans from Columbia, South Carolina, also Jamaica and St. Thomas. As I said, this was very difficult work going to the Caribbean. We also, for comparative purposes, included European Americans from Baltimore. For some strange reason, I couldn't recruit whites when I was at Howard University. I don't know. So I had to call my buddies up at Hopkins and ask them for some samples. I did the reverse of what they normally do to me. So here we see a summary of the Y chromosome diversity in the populations that I mentioned. And you notice there's a lot of haplotype diversity, I mean quite high, over 98% for the most part for all the populations, except, what was it? The Euroho were kind of low. When we look at the Y chromosome, the YAP insertion, the Y-ALU polymorphism, also was quite high, almost fixed throughout West Africa, except in the Hausa in Nigeria, which are a very distinct cultural group and nomadic, and in the Americas was quite low, reflective of admixture with European men of European descent. So when we look at the lineages in the Americas, what we found was FST of about 18% for the Y chromosome across those four populations in the Americas, and the estimate of admixture of European paternal ancestry in these populations was actually quite high, ranged from 30 to 40%, depending on where you were. The lowest being in South Carolina, the highest in Jamaica. And as I mentioned, so this would be reflective of European gene flow into the African American population, what we call sex-biased gene flow. And it didn't start with the influx of tourism in the Caribbean. This actually started a long time ago during the period of slavery. So anyway, we look at the FSTs for the West African populations. We find it also quite high. We look across the regions. It's about 32%. And within these particular regions, of course, they were lower. But the Bight of Biafra was quite interesting. This is the area in Cameroon. It was about 29%, quite rich in diversity there. In the Americas, as I mentioned, it was about 17, 18%. We looked at the relationship of the populations across the first two principal components. We found that the African Americans of South Carolina actually had close affinity with the Mandinka and the Mende and Temne and Kru from Sierra Leone, much closer than, for instance, the African Americans in Washington, D.C., or the Caribbean populations. So if we look at the data, it suggests that there's significant Y chromosome heterogeneity across geographic regions and within areas in the Americas due to the diverse West African ancestry and admixture differences. And in West Africa in particular, genetic ancestry was structured across geographic regions. We also found that, of course, a large contribution of European paternal ancestry across the Americas, and our principal component analysis supported the significant grain coast ancestry of African Americans in South Carolina. So what does this actually mean? Why is this important? Well, I think we all know that we need to take population structure into account when we look at complex disease, gene mapping, and admixed populations. But in particular, we need to explore diverse West African populations. Beyond just the Yoruba, as I mentioned earlier, for impact on disease risk in African Americans. This is an example that I'm going to show you. I also do a lot of cancer genetic work, and my main focus is prostate cancer. And so I thought it would be interesting to look at some of the risk alleles that we found in African American populations in the context of West Africa. And so this was just one of the big GWAS studies we published last year, where we looked at over 3,000 African American men with prostate cancer and over 3,000 controls. One of the findings we had, and which is consistent across multiple studies, is this region on chromosome 8, actually 8q24, extremely large effect there, and when we look specifically within that region, there are actually multiple independent regions of risk within a 1.5 to megabase region. There's actually 4 regions of risk. This shows 3 of them. This region 1 was first discovered in the Scandinavian population, and region 3 and 2 were discovered shortly after that. Probably the main region for African descent populations is region 2. And what's fascinating is that there are no genes in this area. It's a gene desert. So there is something going on that's quite different, or at least it's not classical sort of genetic understanding. So our group, in collaboration with John Carpton, who I think will be speaking later in the conference, looked at this region in a group of African American men and found a 4th region of risk along 126 megabase, which is about 2 megabases upstream from the initial findings of those 3 independent regions. This is around RS 700-8482. So these were, this finding was in over 1,000 African Americans from Washington, D.C. and Chicago. So we then said, okay, well, let's look at these particular regions of risk in West Africa to see if they confer the same level, or even, in fact, if they confer risk in West African populations for prostate cancer. As I mentioned earlier, region 2 is the interesting region. There's an ALU insertion here. There are several SNPs in this region that confer large effects on risk. One in particular is a SNP that was discovered by a group at Harvard, and they said it was African specific. It's called the Broad SNP. It's about 6% in frequency in African Americans, not found in any other population. So, of course, that was one of the first SNPs I wanted to explore in West Africa, to see if it was indeed West African specific. If we look across those 4 regions at the allele frequencies of these risk variants, what we find is for West African populations, quite high allele frequencies for these 4 regions in terms of risk alleles. And African Americans, of course, being high too because of the West African ancestry. And European and Asian populations substantially lower in frequency for these risk alleles. So actually these this region of risk, chromosome AQ24, may actually account for a lot of the disparity that we see in prostate cancer between African Americans and European Americans. So we went into Africa and looked at these AQ24 risk alleles in not only West African men, but also Caribbean men. This was a study where we were able to work with collaborators in Nigeria, in Cameroon, and in Jamaica. Once again, very hard to do in the wintertime. Our initial finding when we looked at over 10 SNPs within that AQ24 region, the 2 SNPs that were in region 2 actually were significantly associated with risk in all of the populations except for the Caribbean population. So we saw it in Cameroon and also in Nigeria and then in the pooled samples from West Africa. We also looked at the 4th region of risk that we found, John Carpenter and I, and that's 700-8482, and also found that it conferred some level of risk in West Africa also. This is a very common SNP in West Africa, so you need a very large sample size in order to see an effect, but it appears that there is an effect there in West Africa. So anyway, I just wanted to acknowledge some of my lab and collaborators. Jada did the work with in the Caribbean and also the paternal lineage study in South Carolina. Stanley Hooker, who is now at Baylor. Wendy and Ken are my, well, Wendy's my graduate student. Ken just recently got his PhD. Is he here? He's around here somewhere. He's always in the back somewhere. Anyway, he just got his PhD, and I'm looking quite excited to see how he develops in this postdoc. And also want to thank the collaborators for the various studies that I talked about. Thank you. You really want me to say something else? No, how much? Oh, okay. I thought I had to take questions. Well, I could have talked more then. Well, I guess what I was trying to get across today was that ancestry is quite important, not just for African Americans to understand their family history, but also in the context of disease. And I showed a glaring example, which is prostate cancer, where we know there's a strong genetic effect. Most health disparities, though, do not have a significant genetic effect that accounts for the disparity. They may be genetic diseases, but there is no sort of this enrichment of these risk alleles that are accounting for the disparity. But prostate cancer, I think, is one of them. And so I thought it was interesting, given that I was talking about Y chromosomes in men, to show this variation across West Africa. I will say, when we look at this table here of these risk alleles across these groups, there really isn't any evidence or strong evidence of genetic heterogeneity across populations, which we found to be interesting. The Cameroon population were Bamileke from actually the I believe Yaoundé or the Douala area, and the Nigerian populations were Benin from the Edo state. So both of them were quite rural populations. They weren't, they didn't have traditional sort of this, I mean, they had traditional diets. They didn't have the westernized diets. So they were quite informative. And it took a while, given that, prostate cancer is a late onset disease, and many folks in West Africa die of infectious disease earlier than the time to develop prostate cancer. But we were able to show that, and also that PSA, which is the biomarker for prostate cancer, is also elevated in West Africa in similar proportions as we see elevation here in the Americas among African Americans. So I think that was also quite interesting too. This, which may reveal that there is this increased burden of prostate cancer also in West Africa. So anyway, I'll end there.
All right. Okay. Thank
you. Okay. Thanks. We thought that we were going to run out of time, but we got a little extra time. What I suggest we do is we can start our break a little bit early, and then come back, and we'll be hearing Carlos Bustamante. And Carlos, are you here? Oh, there you are. Okay, great. So let's go ahead and start the break. There's some food out there for us, I believe, and we'll pick up again at I think it's 10:05. Okay.